Happy morning, dear students. Today we are going to see about fuzzy logic. Okay. Uh, Basic concepts of fuzzy logics. So, what is fuzzy logic? Then introduction to fuzzy logic, classical set theory, mathematical representation of set, types of sets, and operations on classical sets. Okay, today we are going to see these topics. First, let us see about fuzzy logic introduction. Okay. What does fuzzy means? Do anybody know what is fuzzy? Fuzzy means confusion. Okay, that is not clear. That is called as fuzzy. Okay. So this fuzzy logic is used for developing so many algorithms. Okay, it's mainly in studied in the mathematics only. Okay, our soft computing subject, as I said earlier, is a combination of biology, physical science, all the science, okay, including maths also. So in this session, we are going to see about fuzzy logic. It deals with mathematics terms. Okay, so the word fuzzy refers to things which are not clear or it is vague. Okay, that is we cannot define it clearly. That is called as fuzzy. Okay, this state is called as fuzzy state. Next, any event, process, or function that is changing continuously means then we call it as fuzzy. Okay, we cannot always be defined. Okay, like a boolean means we know that true or false, one or zero, like yes or no. Likewise, we can define it, but in fuzzy we cannot define it exactly. Okay, so which means that we need to define the activities in fuzzy manner. So what is fuzzy manner? Fuzzy manner means there is range of values. Okay, in boolean we say it as 0 or 1. We can define it. Okay, it is present, absent. Likewise, we can define it. But fuzzy means we cannot define it clearly. So how we can define means by the range of values. For example, from 0 to 1, 0.01, 0.1, 0.05. Likewise, there will be some range of values which cannot be clearly defined. Okay, that is called as fuzzy. Okay, so what is fuzzy logic? Fuzzy logic resembles the human decision making methodology. Okay, how the human we make decisions, how we make decisions, we will think it in multiple views and then we will take decision, isn't it? So similarly, this fuzzy logic will also resembles like human decision making methodology. Okay, so it deals with vague and imprecise information. Okay, vague means not clear. Okay, we cannot define it clearly. Likewise, imprecise means the answer is not accurate. Okay, so this is a gross oversimplification of the real world problem and based on the degree of truth rather than usual true or false or 1 or 0 or yes or no like Boolean logic. Okay, so we cannot define clearly. That is called as fuzzy logic. Okay, so it consists of the values, ranging values. That is the degree of truth. We cannot say it as true or we cannot say it as false, but it is in some range of values. So you just take an real time example. For example, there is a student called some Prashant. Okay, did the Prashant have knowledge or not? What is the answer? Can we say he has knowledge? It means how many percentage? Can we define it clearly? No. He have knowledge, but he is not able to have all the knowledge. Isn't it? We have some knowledge. So we cannot define it clearly. Okay. So, but we can ask another one question. You see, whether the Prashant have red color shirt. What may be the answer? If we have that red color shirt, then we can say yes. Otherwise, no. That is called as clear answer. Okay, this clear answer will not be available in the fuzzy. Okay, what happens means it has the range of values. Okay, range of values. Okay, now let us see the fuzzy system. The values are indicated by number. Okay, how means between the 0 and 1. Okay, between 0 and 1. Okay, so here you see this 1 represent absolute truth. Similarly, 0 represent absolute falseness. Okay, 1 means absolute truth, 0 means absolute falseness. Okay, so the number which indicates the value in fuzzy system is called truth value. Okay, the number which indicates the value in fuzzy system is called truth value. See here, this is the example. Okay, let us see. Is Rom honest? Okay, we can give the answer true or false, yes or no, 1 or 0. This combination is called as Boolean logic. Okay, true or false, yes or no, 1 and 0. That is called as Boolean logic. Okay, but in fuzzy, what happens means what are the different combination means you see here is Ram honest, extremely honest, very honest, sometimes honest, extremely dishonest. So extremely honest means 1. Extremely dishonest means 0. Okay, so very honest means 0.85. Sometimes honest means 0.35. Likewise, we can give some values between 0 and 1. That is called as fuzzy logic. Okay. Are you clear about this fuzzy logic? Okay. Next, let us see. We can also say that fuzzy logic is not logic that is fuzzy, but logic that is used to describe the fuzziness. Okay, to describe the fuzziness, we are using the fuzzy logic. Okay, that is the main thing to be remembered. Okay, all the values is not fuzzy, but we are using this logic to describe the fuzziness. Fuzziness. Okay, so there can be numerous other examples with the help of which we can understand the concept of fuzzy logic. Okay, there are so many real world problems available in the fuzzy logic. Okay, let us see who introduced this fuzzy logic. It's introduced by Lofty A. Zach in the year 1965. Okay, so how he introduced means he introduced this concept in his research paper called fuzzy set. Okay, so he is called as father of fuzzy logic. So who is father of fuzzy logic? Lofty A. Zadar. Okay, in which year he introduced? In the year 1965. So let us see about the fuzzy logic and classical set theory. Okay, so classical set theory means normal set theory, what we have studied in the mathematics. Okay, that is called as classical set theory. Okay, so what is a set? A set is an unordered collection of different elements. Okay, so the collection of element is called as set. Okay, in general, we can call set is a set bracket. Okay, so how we define? We define now in normal set theory within the bracket we define the list of elements. Okay, the order of element is changed or any element of set is repeated, it does not make any changes in the set. Okay, that is if the order of element is changed or any element of set is repeated, it does not make any changes in the set. Okay, see the example: set of all positive integers, set of all planets in the solar system, a set of all the states in India, a set of all the lower class letters of the alphabet. Okay, these are the examples for set. Okay, so set is the collection of elements and it consists of any elements any number of times. Okay, next let us represent it in the mathematical format. There are two different types, that is roster or tabular form and set builder notation. Okay, now let us see about the roster or tabular form. Okay, in this form, a set is represented by listing all the elements comprising it. Okay, it is represented by listing all the elements comprising it. The elements are enclosed within the braces. Okay, as usual, we represent all the elements in the braces and separated by commas. So, following are the example of set in roster or tabular form. You see here, we are representing English alphabets in set A. That is set A is equal to A E I O U. Similarly, you see here set of odd numbers less than 10. Okay, set B is equal to 1, 3, 5, 7, 9. So, likewise, we are representing the set. Okay, so a set is a collection of elements. We can represent any elements or any number of elements in the set. Okay. Next, we are going to see about set builder notation. Okay. So, what is set builder notation? The set is defined by specifying a property, okay, that elements of set have in common. That is called as set builder notation. Okay, so how we here we describe means, you see A set A is equal to, within the bracket we have to give x is ratio P of x. Okay, so x is the elements that is in the set. Okay, so you see the example, the set A E I O U can be written as set A is equal to x of x is a vowel in English alphabet. Okay. Similarly, we can also represent the odd numbers less than 10 as set B is equal to x 1 x is 1 less than or x less than 10, and it is x divided by 2 is not equal to 0. Okay, this is called as set builder notation. If any element x is a member of any set S, it is denoted by x belongs to S. And if an element y is not a member of set S, it is denoted by y not belongs to S by using the symbol. Okay. For belonging, it is represented as E, whereas for not belonging, it is represented as that element crossed. Okay. So example, if S is equal to 1, comma 1.2, comma 1.7, comma 2, then 1 belongs to S, but 1.5 not belongs to S. Okay, wow. Next, let us see about the cardinality of a set. Okay, so cardinality of a set, yes, denoted by S is the number of element in the set. Okay, for example, you see in the English alphabet, we have seen A, E, I, O, U. So the cardinality of the set is 5. Okay, the number is also referred as cardinal number. Okay, so the number is also referred as cardinal number. The set has infinite number of elements. Its cardinality is infinite. Okay, you see here in the first set there is 1, 4, 3, 5. So the cardinality is 4. And also in the second set you see 1, 2, 3, 4, 5, etc. So the cardinality is infinite. Okay, if there are two sets x and y, and x is equal to y denotes by between two sets x and y having same cardinality, then it occurs when the number of elements in x is exactly equal to number of elements in y. There is no need for same elements, but the same number of elements. Okay, so here the count is the very important. Okay, so if x if less than or equal to y means, then it denotes the x cardinality is less than or equal to set y cardinality. Okay, it occurs when number of element in x is less than or equal to that of y. Okay, here there exists an injective function f from x to y. Okay, so when x is less than y means, then it denotes that set x cardinality is less than set y's cardinality. It occurs when the number of element in x is less than that of y. Okay, so here the function f from x to y is injective function but not bijective. Okay, so if x is less than y and x is less than or equal to y and x is equal to y, then the set x and y are commonly referred as equivalent sets. Okay, that is two sets have equal number of set elements, then it is called as equivalent sets. Okay, next let us see about the types of sets. Okay. So we said that set is a collection of elements, isn't it? So the set can be classified into many types, some of which are finite set, infinite set, subset set, universal set, proper set, singleton set. Likewise, there are so many types of sets available. Let us see each one. Okay, so first one is finite set. What is finite? As we all know that finite means countable number of elements. Okay, for example, in the English alphabet there is only 5 elements, so it is countable. It is called as finite set. Okay, that is countable number of set is called as finite set. A set which contains a definite number of elements is called finite set. Okay, see the example here. Set S is equal to x of x where belongs to nature n. N here stands for natural number, and 70 less than x and less than 50. That is the range of values between 70 and 50. Okay, so we can easily count and say that there is 20 numbers of elements. Okay, next one is infinite set. So what is infinite set? We cannot count the elements or number of elements. That is called as infinite. That is uncountable. Okay, a set which contains infinite number of elements is called infinite set. Okay, see the example here. S is equal to x of x where natural numbers x is greater than 10. Okay, so we cannot exactly count. Next one is subset. A subset X is a subset of set Y. Okay, a set X is a subset of set Y. We are representing using the symbol. This you see in the PPT. If every element of X is an element of set Y, okay, then it is called as subset. Okay, you see here X has the element 1, 2, 3, 4, 5, 6, whereas Y has 1 and 2. So the elements in Y are present in X, isn't it? So 1, comma 2 is available in X. Set X also. So here set Y is a subset of set X, as all the element of set Y is in set X. So we can write it as Y is a subset of X. We cannot say X is a subset of Y, isn't it? Because it consists of 6 elements and Y consists of only 2 elements. So we can say it as a Y is a subset of X, but X is not a subset of Y. Right. Next example, let us see. X set has 1, 2, 3, and also Y set Y, which also consists of the same elements 1, 2, 3. Okay, so here set Y is a subset of set X, as all the element of set Y is in set X. Hence we can write Y is a subset of X and also X is a subset of Y. Next, let us see about the proper subset. Okay, so why we use the term proper subset means can be defined as subset of but not equal to. Okay, that is subset of but not equal to. The set X is a proper subset of Y if every element of X is an element of set Y, that is set X is less than set Y. See the example here. X set X has the element 1, 2, 3, 4, 5, 6. Similarly, Y is equal to 1, comma 2. So here set Y is a subset of X, since all the elements in Y are contained in X, and X has at least one element which is more than set Y. So it is called as proper subset. Okay. Next, let us see about the universal set. So what is universal set? This universal set is a collection of all the elements in a particular context. Okay, that is collection of all the elements. For example, all the planet in the universe. The example for universal set. Okay, all the natural numbers. This example for universal set. Okay, so all the set in that context or applications are essentially a subset of universal set. Okay, so the universal set are represented by using the symbol U. Okay, you see the example. We may define U as the set of all elements on earth. Okay, so all the elements, it can be domestic animal or wild animals. Likewise, all the elements. Okay, we can define it as universal set. We are representing using the symbol U. Okay, in this case, a set of all the mammals is a subset of U. Okay, and a set of all the fishes is a subset of U, and a set of all the insects is a subset of U. Likewise, we can define so many things. So, universal set means it contains all the elements, right? Now we are going to see about empty set or null set. As the name indicates, empty means nothing is there, isn't it? So the element with no elements or without any element is called as empty set, or we can also call it as null set. Right. So empty set containing no element is called empty set or null set. Okay. This unit is likewise. Okay. As the number of elements in an empty set is finite. Empty set is a finite set because there is no element. So 0. We can there is 0 is one of the element, so we are giving it as finite set. The cardinality of empty set or null set is 0. Okay, the cardinality is null set. For example, you see here x belongs to n, the number between 7 and 8. Is there any number between 7 and 8? No, so it is nothing. So it is represented by null set. Next one is singleton set or unit test. A singleton test or a unit set contains only one element. A singleton set is denoted by S. Okay, S within the bracket. You see here, for example, set S. Set S is equal to x of x belongs to n, comma, the values between 7 and 9. So what is the value between 7 and 9? 8. There is only one value. So it is called as singleton set. Okay. Next we are going to see about equal set. What is equal set? If two sets contain same element, they are said to be equal. Okay, so how it contains same elements? Let us see the example here. See, set A consists of 1, 2, 6. It consists of 43 elements, that is 1, 2 and 6. Okay, the set B consists of 6, 1, 2. So, it consists of totally 3 elements, that is 6, 1, 2, which is already present in set A. It consists of 1, 2 and 6. Okay, so all the elements in set A and set B are same. So they are called as equal set. Okay, it consists of same number of elements and also same elements. So they are equal. as every element of set A is an element of set B, and also every element of set B is an element of set A. So it is called as equal set. Are you clear? Okay. Next, let us see about the equivalent set. So when we say it as equivalent, means if the cardinality of two sets are same, then they are called as equivalents. Okay, you have to make a note here, that is what is equal set and what is equivalent set. For equal set, there should be same number of elements and the element must also be same. But whereas in equivalent set, there should be only equal number of sets. Okay, see the example. If A is equal to 1, 2 and 6, B is equal to 16, 17, 22. A set has 3 elements, whereas B set also has 3 elements. So both the sets are same because they have equal number of elements. It is called as equivalent set. Okay, they are equivalent as cardinality of A is equal to cardinality of B. So what is cardinality means? Number of element in the set. So both the set have same number of element. So it is called as equivalent set. Okay. Next is the overlapping set. Okay. Two sets that have at least one common element are called overlapping sets. Okay. Two sets, if they have at least one common element, then it is called as overlapping of sets. Okay, for example, you take set A is equal to 1, 2, 6 and set B is equal to 1, 16, 17. So both have same element of 1. So it is called as overlapping. Okay. You see here it is given set A consists of 1, 2, 6, whereas B consists of 6, 12 and 42. There is a common element called 6 between set A and set B. So it is called as overlapping set. Right. Next, let us see about the disjoint set. Okay. Two sets A and B are called disjoint set if they do not have even one common in elements. Okay. Then it is called as disjoint. For example, you see that is set A consists of 1, 2, 6 and set B consists of 7, 9 and 14. Okay, there is not even a single common element between set A and B. So it is called as disjoint set. Okay, so there is not a single common element, hence these sets are overlapping sets. Or these sets are not overlapping set, so it is called as disjoint set. Next, let us see about the operations on classical sets. Set operation include set union, intersection, difference, complements, and partition product. Okay, these are the main operations performed on classical set theory. This classical set theory is also called as crisp set. Okay, so first let us see about the union. The union of set A and B is denoted using the symbol U. Okay, A union B is a set of elements which are in set A and in B or in both A and B. Okay, so hence A union B is equal to x of x such that A or x belongs to B. Okay, all the elements, for example, the set elements in set A and also set B combinedly is called as union operation. You see here, example you hear, A is equal to 10, 11, 12, 13. B is equal to 13, 14 and 15. Okay, so here A union B means we will combine all the set from all the elements present in set A and also the elements present in set B. Okay, so A union B is equal to 10, 11, 12, 13, 14, 15. Okay, so the common elements can be given only once. That is called as A union B. Okay, next let us see about the intersection. Okay, so what is intersection? Intersection means the finding the common elements. Okay, what are the common elements between two sets? That is called as intersection of set. Okay, so you see here A intersection B is the set of elements which are in both A and B. Okay, so it's represented by intersection symbol N. Okay, the elements which are present in set A and also in set B is called as intersection. Okay, you see in the previous example how we can give 10, 11, 12, 13 in set A and the elements in set B are 13, 14 and 15. Okay, so how can we give intersection? 13. 13 is present in set A and also in set B. So the intersection consists of the element 13. Okay, next we are going to see the difference or relative complement. Okay, so what is the difference? The difference, as we say normally, set A and set B are there. All the elements in set A which are not present in set B is called as difference. Okay, so all the elements which are present in set A but not present in set B are called as the difference. So the set difference of set A and B is represented by A minus B. Okay, it is a subset of elements which are only in A but not in B. That is given as A minus B. Okay, so the elements which are present only in set A and not in set B is called as difference or relative complement. Okay, so the example here, set A consists of 10, 11, 12 and 13, whereas B consists of 13, 14 and 15. So the A difference B gives 10, 11, 12. Okay, because these are not present in set B and the element 13 is common in both. So it is left over in the set A. So the element consists of 10, 11 and 12. Okay. So whereas B difference A means what happens you see here 13 is a common element which is present in the set B. Okay. So next one is 14 and 15 are the elements which are not present in set A. So 14 and 15 are the different complements. Okay. So here you see we can say A difference B is not equal to B difference A. Okay. These are the operations on the classical sets. Do you have any doubts, ma? See the reference.